Alright, so let us look at what we had done in the previous class. In the previous class, we had solved a system of equation and we had got the augmented matrix. I have written them here itself, alright, to make you understand certain things. So here what you see here is in the first part, we just wrote the augmented matrix, second part also, third part also. But how did I obtain the second part? The second part was obtained by looking at second equation minus 2 times the first equation. That was the idea, that we subtracted 2 times the first equation from the second equation, all right. So let us look at the identity matrix. This matrix is size 3 cross 4. I want to multiply a matrix on the left, all right. So I want to look at the identity matrix which is 3 cross 3. Is that okay? I want to look at this matrix, identity matrix, which is of size 3. Now, if I multiply this matrix to B0, so if I want to look at I3 times B0, I will get B0, all right, because it is an identity matrix. I want to change I3 in such a way that I want to get B1, all right. So the idea is I want to change I3, all right. I want to do something to I3, multiply it to B2 and get B1. Is that okay? The idea is do something to identity and get B1, fine. So what we see is that coming from the first equation to the second part, first part to the second part, the first equation or the first row of the matrix did not change. The first row of B0 and the first row of B1 is still the same. So since the first row is the same, I just write 1 0 0 times B0, because 1 0 0 times B0 will give me the first row, all right. I also see that the third row of B1 and B0 is also the same. Since they are the same, so I can just replace by 0 0 1, nothing to be done. Is that okay? We have replaced second equation by 2 times the first equation. So if I just write here 1 and 0, it means that it is 1 times the second row and 0 times the third row. What we are doing is second equation minus 2 times. So minus 2 times the first equation. So I already have the second equation with me. I want to minus 2 times the first equation, so I write minus 2 here. So I would like you to check here that minus 2 times this B0 will give me B1. So just multiply here. So just let us look at this. So minus 2 times 1114 plus 2035 plus 0 times 0113. This gives you 2 minus 2 is 0, 0 minus 2 is minus 2, 3 minus 2 is 1 and 5 minus 8 is minus 3, which is nothing but the second equation of B1, second row of B1, all right, fine. So whatever we could do here for the system of equations, subtracting one from the other or doing something, I am able to get it by matrix multiplication. Now let us go from the second part to the third part, all right. So again I want to multiply here something to B1, all right. So if I look at B1 and B2, all right, the first row of the 2 is the same. So I just keep it as it is, first row is the same. So 1 0 0 times B1 will be the first row of B2. Second row of B2 is also the same as the second row of B1. So I don't do anything here, it remains as it is. Now I am doing third equation is being replaced by third equation plus half times the second equation, all right. So the third equation I am not doing anything. I am not playing with the first row also. So the first row I am not doing anything, so it remains 0 here. We are looking at only third equation plus half times the second equation. So second equation is being multiplied by half. So I just write half here because it was half and I am adding it, so there is a plus sign here. So I would like you to see here that it is 0 times 1114 plus half times 0 minus 2 1 minus 3 plus 1 times 1 1 3, all right. So, these are the entries of B1, they are coming from B1, all right. So, I would like you to see that this is 0, here it is nothing but minus half. So, this is equal to 0 minus 1 half, and this is minus 3 by 2. So, it is minus 3 by 2 plus 0 1 1 3, which is 0 0 1 plus 1 by 3 is 3 by 2, 3 minus 3 by 2 is 3 by 2, which is nothing but the third row, all right. So, the question is it just a chance factor or it does really always hold, all right. So, if you see what exactly we have done is that we had the identity matrix. The first part was replace or look at second equation minus 2 times the first equation, all right. I had done that for system of equation. Look at I3. If I look at the second equation of I3, minus 2 times first row of I3, I do get here second row of I3 is 0 1 0, and this is minus 2 times 1 0 0, and I do get back this part. Look at that, minus 2 1 0, this is nothing but the second row here, all right. Similarly, here also I would like you to see that I am looking at third equation. So, third row of identity plus half of second row of identity. So, it is 0 0 1 plus half of 0 1 0, which gives me here the third row, all right. So, whatever I am doing here to the equation, I am doing a similar thing to the rows of identity matrix and then just multiplying to get my things. Is that okay? So, this is what you have to be careful about, that you are able to get them through matrices, all right. Now, one thing extra that you need to know that will come to afterwards is that if from identity I can get back this equation 1 0 0 minus 2 1 0 0 0 1, can I go back from here to identity? Can I go back? All right. The answer is yes, you can go back, and if I want to go back to this matrix, I would like to just look at second row plus 2 times first row, all right. So, look at the second row is minus 2 1 0 plus 2 times the first row, and this is nothing but this gives me minus 2 plus 2 is 0, all right. 1 minus 0 is 1 and this. So, I get back the second row as it is. Is that okay? Similarly, if I look at the third part here, can I from this matrix can I go back and get identity? So, the first two are the same, I am just changed the third row. So, again I can do the third row. So, look at third row minus half times the second row, and this is nothing but, so third row is here 0 half 1, all right, minus half times the second row 0 1 0. Check that this is indeed equal to 0, half minus half is 0 and this is 1. So, you get back the third row of identity. Is that okay? So, you can see that in some sense I am able to get back the original part, that is the identity. We will look at them in matrix multiplication in the next class, all right. Now, what I would like you to stress here is what are called pivots here. So, if you look at the equation that we had here, augmented matrix, the first row of this augmented matrix, all right, first row of the augmented matrix had a 1 here. This one we say it is a pivot, because we are using this one to make other entries in that column to be 0. Is that okay? So, this one in the first row is a pivot. So, this is called a pivot, and this is the coefficient of x. All right. Is that okay? In B1, this is the pivot. All right. This is the pivot. Fine. So, what are pivots? Look at the rows that you are looking at. In the first row, look at the first non-zero element, that is the pivot. All right. There is no other pivot here as far as 1 is concerned for me for the time being. Now, when I come to the second equation, it is -2, which is a pivot, and 1 was also a pivot coming from the previous part. Fine. So, you have 2 pivots here. This is also a pivot. So, 2 pivots. First non-zero entry. All right. And there is something also which is important is, look at the part which is below. Those things can be made 0 using this pivot. I can use -2 to make this entry 1 as 0. All right. So, therefore, that is a pivot. So, I have a pivot here, I have a pivot here, I have a pivot. So, I have got 3 pivots. Is that okay? So, I would like to understand these pivots and what are called row reduced echelon form. All right. So, first let us look at what is a row echelon form. Row echelon form. So, echelon basically means ladder like for us. In general, it is called a staircase. All right. Fine. So, we are saying it is ladder like. So, look at the pivots. So, a matrix is, so it is a definition that I am writing here, definition. A matrix is said to be in row echelon form if all the 0 rows are at the bottom. So, in the previous example, I did not have any 0 row, everything was non-zero. 2, if the pivot of the I plus 1th row, if it exists, comes to the right of the pivot of the ith row. 3, once you have got the pivots, all right, in certain rows, every entry below that pivot, every entry below that pivot, below the pivots, below pivots are 0. All right. So, let us go back to the previous example and see what we have. So, in the previous example, what we have is that this matrix is in row echelon form. Why? Because look at this, there is no 0 row. So, there is no question of bottom here. We have pivots here, all right, and pivot at the second row is on the right of the first, pivot on the third is again on the right of the second, and so on. Fine. Third part is every entry below the pivot should be 0. All right. So, they are 0 for us. Let us have a better understanding. Also, one thing more I wanted to say. So, why it is called echelon or ladder like? Basically, because what you are looking at, you have these as your pivots. These are the pivots. So, there is a ladder that is coming into play here. All right. So, there is a ladder that is playing the role here. It is not necessary that it has to be at each step. So, let us look at some examples where they are echelon form or not. I would like you to give the answers. So, examples. So, let us look at this matrix. Now, if I look at this, look at the definition, all the 0 rows are at the bottom. Yes, it is at the bottom, there is no problem. If the pivot of the I plus 1th row comes to the right of the pivot of the ith row. Now, what are the pivots here? Pivots are, as I said, it is the first non-zero entry in each row, all right. So, these are the pivots that I have. So, I have pivot here, I have a pivot here. So, these pivots, if I look at, they go to the right here. So, this is the stair that you are looking at here, fine. Every entry below pivots are 0. So, this entry is 0 and below everything is 0. So, this is a row echelon form. Another example of row echelon form, the identity matrix itself. So, you can put here 3, 4, 5, whatever you want to say. So, these are the pivots that you are looking at. Everything below that is 0 and this is the way it appears, fine. Now, example when it is not a, so not in row echelon form. So, let us take an example. Previous example is 0, 2, 4, 2, 0, 0, 0, 0, 0, 0, 1, 1. So, these are the pivots I can see here, these are the non-zero rows, all right. So, I think I forgot to say what is a pivot. So, pivot is, so pivot, the first non-zero entry in a non-zero row. This was the one that I was writing, all right, I had forgotten it. So, that was a mistake, fine. So, again, what is a pivot? Pivot is the first non-zero entry in the non-zero row. So, I have those here. So, this is a pivot, 2 is a pivot, 1 is a pivot here. But if you look at the row echelon form, we have a problem here in the sense that, look at this, the first says that all the 0 rows are at the bottom. Here the 0 row is at the middle place, it is not at the bottom. So, it is not in the row reduced echelon form. I can also have, for example, 0, 0, 1, 1, this is a pivot. I can have 0, 2, 4, 2, again this is a pivot because it is the first non-zero row, and then I can have this, fine. This is not in the row reduced echelon form basically because it is not ladder like. So, not ladder like, or the pivot at the second row comes on the left, not on the right of the pivot of the first. Is that okay? So, this part is getting contradicted. Is that okay? Fine. Not only that, even third part is contradicted. So, I would like you to look at these examples and get something nice for yourself, all right. So, the last part of this lecture is what is called, given a matrix A which is M cross M, would like to write it as A equal to LU. If you remember, that was the idea that we want to decompose A into certain things. So, L is lower triangular and U is upper triangular, fine. So, let us go back to our examples, all right. So, example 1. So, let me write A as 2, 3, 8 and 11 and a simple example 2 by 2, and then we will go back to the third example. So, if I look at this matrix, I would like to make it times A, I want to have it as in the row echelon form, all right. So, there is a 2 here, so I can think of 2 itself as my pivot and have 3 as it is, there is no change as such. I can multiply, so the first row of this remains the same for me, all right. I want to make this entry 0. If I want to make this entry 0, I need to multiply the first row by 4 and subtract. So, I need to multiply the first row by 4 and subtract. Subtract means minus sign and 1 here. So, if you look at minus 4, 1 times 2, 3, 8, 11 is nothing but minus 4 times 2, 3 plus 1 times 8, 11 which is nothing but minus 8 minus 12 plus 8 11, which is nothing but 0, and minus 12, and this is minus 1. Is that okay? So, what we see here is that I have this matrix is lower triangular, and this matrix is upper triangular. Fine. But I did not want it as lower triangular times A, but I wanted A to be in terms of lower and upper triangular. So, I would like to take the inverse of this matrix. So, I want to compute 1 0 minus 4 1 inverse of this matrix. So, inverse of this matrix will be 1 and 1 itself, fine. It will be 4 here, 0 here. So, let us check it out. So, 1 0 4 1 times 1 0 minus 4 1. This is nothing but first row remains as it is. It says that 4 times the first row plus 1 times the second row, 4 times the first row is 4 0 minus 4. So, I get back this here, fine. So, this is indeed the inverse of this. So, I can write A as 1 0 4 1 times 2 3 0 minus 1. So, I have been able to write A as a lower triangular and an upper triangular, fine. So, before I move to the next example, I would like you to see that suppose I have a lower triangular matrix L1. So, L1 and L2 are both lower triangular. Then what can you say about the matrix product L1 L2? Can I say that L1 L2 is also lower triangular? So, let us understand this. So, I have some entry here, 0 here, 0 here, fine, a star here, 0 here. So, I have these entries with me. This is L1. I have L2, which is again of similar type. Can I say that everything is nice here? Fine. So, I want to show that this entry I am not bothered about. I want to show that this is 0. Now, what is this entry? This entry is first row of this times the second here, all right. So, this entry here is nothing but, let me write it here. I think that entry is the 1 2 entry. So, it corresponds to first row of L1 times second column of L2. So, if you look at the first row of L1, there is a star here, you have to multiply with 0 here, then 0 here has to be multiplied with this star, and this 0 has to be multiplied with this star, and therefore, it is 0, fine. Similarly, the 1 3 entry is also 0, this entry is also 0, all right, because I have to multiply first row of L1 with the third here, fine. So, it is a star times 0, 0 times 0, and 0 times a star, which is 0, all right. So, just check that L1 into L2 is also 0, all right. As the last example for now is the previous example that we had done. So, in the previous example, we had our augmented matrix was 1 1 1 4 2 0 3 5 0 1 1 3. This was my B0, and my B2 was 1 0 0 1 minus 2 0 1 1 3 by 2 and 4 minus 3 3 by 2. So, here it is not a square matrix. So, it is not a square matrix. If you recall, I had said that we would like to look at the form, upper or the lower triangular form, but I can still do this. I can look at these two together, forget about this part, and therefore, if you see what we had done was, let us go back. So, the first thing we had done was to remove this. So, I had this matrix with me 1 0 0, all right, 0 0 1 times 1 1 1 2 0 3 0 1 1 as something, all right. So, this was minus 2 here and 1 here, 0 here, and that gave me 1 1 1 0 1 1 0 minus 2 1. This is what I got, fine. In this, so given this matrix 1 1 1 0 minus 2 1 0 1 1, we have 1 1 1 0 minus 2 1 0 0 3 by 2. So, here I had looked at the third one. So, it was 1 0 0 0 1 0. So, you have to multiply half here, had half here, this is what I had this. So, if you see on B 0, first we multiply this matrix which is L 2 for me, and then L 1 here to get me B 2. Is that okay? So, what I see here is that if I write this as my 1 1 1 2 0 3 0 1 1, then the inverse of this L 1 L 2 whole inverse times this part 1 1 1 0 minus 2 1 0 0 3 by 2 is the one that I am looking at, A equal to Lu. You can see that this is upper triangular, all right, and L is nothing but inverse of L 1 L 2. L 1 is lower triangular, L 2 is lower triangular. So, their product is lower triangular, and hence L is lower triangular for us. So, we have been able to write A as Lu. Is that okay? So, in general, there is a way of doing these things. What are the conditions and so on, that will come in the next class. Thank you.